Hello, welcome back. In this segment, I will explain how to represent a well-formed formula as a binary tree. So in the previous segment, we talked about a well-formed proposition logic formula like the one that you're seeing here with not P and Q implies and so forth. So we can also visualize this linear representation as a binary tree. So if you look at the structure of this formula, right, this arrow mark is the topmost node because we can divide this representation into two parts. One is this portion, right? Not P and not Q as one portion, and then P and Q or not or is another portion. So the root is arrow mark. So we can have a binary tree rooted at arrow mark. That's the first level. Left subtree is not P and Q. Okay, so we have to have branches, left and right branches. On the left-hand side, we would have not P and Q. Okay, so the left subtree is not P and Q. And again, we have to apply the same rule. As you can see here, and is the root for the next level. We're talking about this subformula, right? We have and now another subformula is not P, Q, right? So we can stick it in a Q somewhere, let's say Q here, and we need to work on the not P. So for not P, we just put a not here and a P here. So it doesn't matter whether P is a left or right subchild, but this is basically the left side. We are done. Now we can do the right side. Again, the and is the sort of the root connector, and we have a P on the left-hand side. So we are done with left-hand side. Okay, on the right-hand side, we have Q or not R. The R becomes the root, and the Q is the left child. And again, you have a right child with a not and an R. Okay, so this is how we can represent a logical formula as a parse tree. This tree is called parse tree. If you traverse this tree in order, you can actually go back from this representation back to the linear representation. So this is linear representation, right? One line, you write it. And this is the binary parse tree representation. So if you start your in-order traversal, right? In-order traversal means go to the left subtree, explore the left subtree completely, and then root, and then the right subtree, you will get back the original formula. In the next segment, I will show you how to do the in-order traversal and check whether a given formula is valid or not using the binary parse tree analysis. Okay, so in this segment, we saw how to take a well-formed formula and represent it as a binary parse tree. We don't have to worry about the brackets in the binary parse tree. That is a benefit. We can easily see root connector is implied, and that's basically what you're seeing here. And then you have to traverse the left subtree. For example, and is the sort of the root connector for the left subtree. That's what you're seeing here. Similarly, on the right-hand side, and is the connector for that right side formula. And you can keep navigating left and right subtrees to figure out the original formula from the tree representation. Okay, that's all. Thank you very much for your attention.